All right. Welcome to PK is out on Tuesday, September 17th. My agenda, our test is still on Thursday. Test Thursday. Not going to go over much with you guys, and you will have time to practice today. So, our agenda. We are going to review the daily quiz that just got passed back to you. It is not graded. It is not going into Power School. Just accept this one as a freebie. We will review graphing. You do not have to use the graphing calculator, so I'm not as worried about that right this second. We will talk about the quadratic context questions, and then you will be using Delta Math to study and coming up with your note sheet. So, with regards to the daily quiz. Okay. So first of all, take a look at the first question. What form is that in? You're right. It's in factored form. It's already been factored for you. Remember, I told you guys to be efficient. So since you're being efficient and it's already factored, we just set each factor equal to 0 and solve it from there. You do not have to distribute. If you distributed and then factored, you should have come up with that, which again, not efficient. If you distributed and used the quadratic formula, again, not efficient, not the best way to do these things. Since it's already set up like this, all we're going to go ahead and do is solve for x. X is equal to positive 3 halves, and x is equal to negative 10 over 4, which we should simplify to negative 5 over 2. The question got asked, should we simplify our fractions? My answer is always yes, you should try to simplify your fractions. You have access to a graphing calculator that will do it for you. That's the one version. If you had the other version, the other two answers was what x is equal to negative 3/4 and x is equal to negative 5. So check your work. Second question. Is there an x term? No x term? Since there is no x term, what method should we have used to solve it if these are the three methods of solving? Ding, ding, ding. You should have used square roots. So we're going to use square roots by adding 12 to both sides. 4x squared equals 12. Before you can take the square root, we do need to get rid of the 4. So we're going to divide both sides by 4. X squared is equal to 3. Now we're going to take the square root of both sides. And x is equal to plus or minus the square root of 3. Again, if you had the other version, your answer ended up x is equal to plus or minus 2. Again, at any point in time, feel free to hit pause, check your work, copy something down, put it in your notes. You do need to create your note sheet, so that is going to be something that you should be working on as well. All right, last one. Last one could be solved by either square root, completing the square, which would be really, really icky because of the negative 13, or the quadratic formula. I will tell you now this one can be factored, but I'm going to review square using the quadratic formula because that's what a lot of you used. But you made common mistakes, and therefore, since you made common mistakes, I'd like to fix those. So it is in standard form. It is equal to 0. Life is good. We identify our A value as 6, our B value as negative 13, and our C value as negative 5. If we substitute into our calculator or substitute into the formula, the opposite of B, the opposite of negative 13 is positive 13, plus or minus the square root. Now here's where we made our mistakes. That negative 13 is not a positive 13, it is a negative 13. So since it is a negative 13, we want to put that negative 13 in parentheses before we square it. A lot of you got a number out of that was a negative, and it should very much have been a positive number. Minus 4 times A is 6, times C, which is negative 5. All over 2 times A, or 2 times 6. So keeping a line, positive 13 square root. Negative 13 squared is positive 169. If you put the negative into your work without the parentheses, then there's a high likelihood that you got negative 169 and then you had issues. 4 times 6 times 5 is positive 120 because of both the 4 and the negative 5 are negative. Negative times negative is positive, all over 12. We end up with 13 plus or minus the square root. 169 plus 120 is 289, all over 12. The square root of 289, it is even. It comes out nicely. It is 13 plus or minus 17 over 12. So your two answers are 13 plus 17 over 12 and 13 minus 17 over 12, which is 30 over 12 or negative 4 over 12, which again simplifies to 5 over 2, divisible both by 5, and negative 1/3. If you solve the second question, the answers were x is equal to negative 1/2 and x is equal to 5/3. Again, on that second question, you needed to watch your b value because your b value was negative. See, -7. So when we square -7, we ended up with positive 49. Okay. So again, check your answers on that daily quiz. All right. Reviewing graphing. If I give you a picture, should you be able to answer all of these questions? I hope so. X-intercepts. There's your x-intercepts. Again, we need to make sure we are writing those as points. So negative 0.6670 and 1.750. Write them as points. Y-intercept as well is given. That is 0.14. Very clearly, this one doesn't open up. It opens down. It has a maximum. That maximum happens at 0.542, 17.521. Now let's talk increasing and decreasing. Actually, let's talk domain and range first of all. Domain is the same for all of these. We're going to go from negative infinity to positive infinity. Our range goes from bottom to top. So if we start at the bottom, we start at negative infinity. We max out at this 17.521. Now, increasing and decreasing. If I go from left to right, so if I start over here on the left side, I start, and this is clearly doing what until we get to this value? It's clearly increasing. So it is increasing from negative infinity up to this x value of 0.542. From there, it flips, and now it is going down. So it starts going down at 0.542 to positive infinity. This shouldn't be a parentheses, people. It should be a bracket because it actually does touch that value. So that's what I'm looking for from the graphing piece. So check done. Review daily quiz, review graphing. Now let's talk about quadratics in context. Okay. Take a second and read that problem. The length of a rectangle is 2 more than its width. If the area of a rectangle is 63 centimeters, find the length and a width. It's a rectangle. What could we do? Because we know what shape it is. Again, remember, you guys are better at this than I am. We should draw a picture. Okay, so with drawing a picture, area of a rectangle is length times width. So the area we already know is 63 centimeters squared. The length is 2 more than its width. So if I label this the width, how do I do 2 more than? Is it addition, subtraction, multiplication, or division? You have 4 options. Okay, if you said addition, you hit the nail on the head. It is 2 more than the width. So now we're just going to substitute this stuff in. We're going to replace area with 63. We're going to replace the length with 2 plus the width. We're going to replace the width with the width. And now we're going to solve this equation because I'm going to distribute. 63 is 2w plus w squared. What type of an equation is this? Hint, hint, we've been doing quite a few of them. That is a quadratic, so we're going to subtract that 63 from both sides. That's 36. 63. W squared plus 2w minus 63 is equal to 0. I don't want to use the quadratic formula. I am going to use the negative 63 to get me positive 2. 1 and 63, 3 and 21, 4, 5, 6, 7, and 9. In fact, negative 7, positive 9 should give me positive 2. Since it is an a value, a squared, a is 1, we can just do w minus 7, w plus 9 equals 0, which gives me positive 7 and negative 9. But since we're actually talking about a legit rectangle, we can identify that which one of those two cannot be the width. If you said negative 9 because a length or a width cannot be negative, you hit the nail on the head. If the width is 7, the length is 2 plus 7, which is 9. So your length is 9, your width is 7. Now, some of you are probably going, hey, PK, I knew that without actually doing any of the math. Remember, this is a test. I am looking to test our ability to use quadratic equations and to solve quadratic equations. You will be expected to write an equation and then solve the quadratic equation. Now, could you use your brain cells and check your work? Absolutely. All right, very similar. We got another rectangle. Again, I like pictures. I like pictures that snap. There we go. Area is equal to 96 kilometers squared. Width is 4 less than the length. So that's width is 4 less than the length. How do I do 4 less than? Is it 4 minus the length? Is that 4 less than the length? Nope, that says the length from 4. So we actually need to flip that around and we need to say the length minus 4. That means 4 less than the length. So if we identify our length and the width as L minus 4, we can set up our area equation. Area equals length times width, which in this case would be length times L minus 4 is equal to 96. From there, we're just going to go ahead and solve it. 96 is equal to L squared minus 4L. Subtract 96 from both sides. L squared minus 4L minus 96 is equal to 0. So we're looking for factor pairs of negative 96 that add up to negative 4. So we're going to be multiplying 96, 1 and 96, 2, and I'm going to get out my calculator because I don't have this memorized. 2 and 48 doesn't work. 96 divided by 3, 3 and 32, that one works. Divided by 4, 4 and 24. 5 doesn't work. Let's see if 6 works. 6 and 16. 7 does not. 8 works 12 times, and there we go, because negative 12, positive 8 would solve it for us. So L minus 12, L plus 8. My two values of L are 12 and negative 8. I'm going to cross off the negative 8 because a length can't be negative. If the length is 12, the width is 12 minus 4, or 8. All right, last two problems, and then I'll let you do some practice. Now, Jason is jumping off a cliff. I did tell you guys we were going to mix some physics into our math because we're going to talk quadratics. So we're mixing physics into math today. Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time can be modeled by this equation. So we have an equation that represents what's going on. T is time and H is height. So we're going to ask ourselves three questions. We're going to say, how long did it take him to reach his maximum height? What was the highest point? And how many seconds will he hit the water? So if I think about this from a physics perspective and from a math science perspective, I know, oh, that's crooked. I know that we are on a cliff. We're going to start at 480 feet above the water. When I jump, he's going to go up just a bit. He's going to go up and then he's going to come back down. This is where he hits the water. This measurement is T. This measurement is height. So what happens? Well, we know he hits his top height at a specific T value. We also know that he hits the ground or hits the water at some value of T. That's our x-intercept, or in this case, a t-intercept. So how long does it take to reach his maximum height? That means we need to identify this point. This point is also known as the vertex. So to find that, we're going to do negative b over 2a. This is where we were last class, folks, with the graphing. To find the vertex, we're going to substitute negative b over 2a. So a is negative 16, b is positive 16, c is 480. So negative 16 over 2 times negative 16. Our negative 16s are going to divide out, and we're left with 1 over 2, which we could rewrite as a decimal of 0.5 seconds. So in 0.5 seconds, he will hit his maximum. So the question is, when I substitute in that 0.5 seconds, how long does it take to reach his maximum? Well, then I'm going to do h of 0.5. So that's going to be negative 16 times 0.5 squared plus 16 times 0.5 plus 480. So now I'm going to get out my calculator. I'm going to do 0.5 times 0.5 times that by 16 negative. That gives me negative 4. 16 times 0.5 is 8 plus 480, which negative 4 plus 8 plus 480 is 484 feet. So what are the coordinates of the vertex? 0.5, 484. Now, how long does it take him to hit the water? That's just an x-intercept. And I don't want to try to factor this one. I'm just going to use the quadratic formula. So T is equal to opposite of B plus or minus the square root of 16 squared minus 4 times 16 times 480. And that's actually negative 16 because it's A. All over 2 times negative 16 or negative 32. So negative 16 plus or minus square root. 16 times 16 is 256. 4 times 16 times 480 is 30,720. Add that to 256. Take the square root of that. It's negative 16 plus or minus 176. all over negative 32. So negative 16 plus 176 over negative 32. Negative 16 plus 176 divided by 36, 32 negative is negative 5. That does not work because negative time does not make sense. Negative 16 minus 176 over negative 32 is positive 6. So we eliminate the negative answer. The answer is positive 6. Positive 6 is when Jason will hit the water. One last example. Same deal. When does the object hit the ground? That's going to be looking for an x-intercept. When does it hit its maximum? That's going to be your t is equal to negative b over 2a. What is the maximum? That's going to be s of whatever t is from the previous one. So if a is negative 4.9, b is 19.6, and c is 58.8, x is equal to negative 19.6 plus or minus the square root. 19.6 squared minus 4 times negative 4.9 times 58.8 all over 2 times negative 4.9. I will tell you the values of t are, phone calculator is not working, so here's my real calculator. T is equal to, I'm doing the whole thing. T is equal to negative 2. Or positive 6. Obviously, negative 2 doesn't work, so positive 6 is my answer. We hit our maximum at negative 19.6 divided by 2 times negative 4.9. That happens at a time of 2. So S of 2 is equal to negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8. Negative 4.9 times 4 plus 19.6 times 2 plus 58.8. 78.4 units are feet. Units are seconds. Seconds. So there are the context problems. So what can you work on to study for the test? 1, create a good note sheet. This might include formulas. This might include methods of solving. This might include examples of them. It might include things about how to complete the square, the forms of quadratics, standard, vertex, Standard vertex factored, what are the key points that we get out of those? Examples, again, you can have the front side of an 8.5 by 11-inch sheet of paper. Okay. Secondly, Delta Math. No, I'm not creating a new Delta Math for you. Go back and work on other ones. I did open one that has context problems, but I would suggest doing some of the other ones as well. Okay. Enjoy the rest of your class. Hopefully you watch this video. This is useful information for you.